Hi there, I'm Joe Shaw. I'm a full stack engineer in the Incubation engineering department, working on application performance management. And I'm going to give a quick demo in this video of current monitoring capabilities in GitLab itself to lead on to the sort of work that we're going to be doing in the next few months to create a SaaS first solution, an agent-based solution to solve this problem. So as you can see here, I've set up a Kubernetes cluster with Minikube, and I've called it Minikube. This is linked to a test server, and you can see here, if you look at my K9s instance, this is a little Minikube cluster I've got on my machine with 3 nodes ready to go. And after a bit of configuration that I'll show you, that's connected to this local GitLab instance that I'm running here. So you can see some information about the cluster. I've managed to get it to connect to a local address, change some of the background settings to do that. And the CA certificate and things like that. It's all local to my machine, so there's no risk in me showing you this. Right, so there's the Minikube instance. And what I've done is I've used an observability repository that I've set up locally, and I will add links into the YouTube comment, YouTube video for that repository so you can see how that works. And I've deployed into my Minikube instance a stack, an observability stack, including a Prometheus operator, which deploys Prometheus and various other services like the node exporter, an alert manager. As well as that, I've installed FluentBit and Elasticsearch to perform logging operations there, and Jaeger as well sat on top of Elasticsearch to do trace monitoring. And this is all running in the GitLab managed apps namespace, which is a requirement to get this running with GitLab itself. And there are specific requirements around service names and things like that. So I'll switch back to GitLab here, and we can click on the health component here, and it loads, and it's making a request to my cluster there. I've no idea what there was an error getting dashboard validation warnings information means. Not a clue. And we can see some basic information about the health of the cluster here, CPU, overall CPU usage and memory usage. And we can narrow that down a little bit there and look at that. And that's just a top level bit of information. If you look at the integrations here, I've just turned on Prometheus for the moment. Elastic Stack and logging I'll cover in another video. And you can see more information about the way that you can actually get Prometheus integrated there. Like I say, you have to have it in a particular namespace with a particular service name running on port 80, which isn't in the docs. So I must create an issue for that. So there's that integrated cluster, and that's set up against a test environment here called production, which doesn't have anything deployed into it, but it's attached to that, so we can easily look at it and set things up. What I can do now is just show you the monitoring space that's set up now. You can see it's hitting production here. Let me change that to 30 minutes so we're not loading too much stuff. Again, that error message, still don't know what it means. Now in this page, I've noticed that obviously there's a lot of integrations here that are irrelevant to my cluster, but they're looking for specific things in the Prometheus instance that this GitLab instance is connecting through to via the API server of this Minikube cluster that I've got. I can't seem to get system metrics to display here. I'm not sure why, but if I change this to K, it's pod health at the top. I can, again, change this to 30 minutes. When it gets to it, and I can pick a pod out of here. So it will actually query into the cluster and get me the pods. So if we have a look at, say, the Elasticsearch master that I've got running in that cluster, give it a moment to catch up, and there we go. We've got some CPU usage there. See, we've had a little spike there. This is all in sort of cores per millicores per container. Memory metrics, as expected, fairly high memory usage for Elastic there, 800 meg. You've got some network spikes there. You can see allegedly not using any disk, which is highly unlikely. So you can see there we can get some basic metrics out, and we can get anything from the, get these from the pods there. And it is possible to customize this, so you can create new dashboards, and those use a specific YAML structure that you can put in your repository to configure all this. And this is how this is all sort of pre-baked in. And you can add a metric here, and you're using the sort of Prometheus query documentation there to get that information out. And then that would add that to those charts, and you can pick any of these metrics and expand that panel and have a look at it. So there we go, and you can explore around and see what's going on there. So it's fairly limited. I have seen that you should also be able to view the logs here. Now, I know there is some implication that you need Elasticsearch, but it should, I think, be able to go into there and pull the logs out. And it doesn't seem to be able to at the moment. I'm not sure why that is. It doesn't seem to be able to pull the pod information, even though we saw that was working in the previous step. So I'm not quite sure what's going on there. The other aspects of Monitor on the side, you can see there are tracing, and all that allows you to do is essentially add a Jaeger URL here to link to. And other areas like error tracking, alerts, and incidents, I'm not going to go into, but they are areas that we'd look to feed into in the future to complete that DevOps cycle. If we look at the Monitor settings generally, here you can see that you can actually configure dashboards, so you can link to an external dashboard, likewise tracing, error tracking, setting up alerts. You can set up a Grafana instance so that you can embed Grafana dashboards in that metrics area there. So there is a certain amount of flexibility built in there. You don't have to use this built-in solution, but it does fit in with the environments quite well. I think that's kind of a quick tour of the sort of top level metrics capabilities that are there in GitLab. What I will do is look at the cluster that we've set up, and what we've got in this cluster. As I said, this Minikube cluster has this chart, and again, I'll put a link to this repository, this project in GitLab under the video, and this sets up Prometheus operator, Elasticsearch Kibana, FluentBit to feed into Elasticsearch, and Jaeger for the tracing. And I will just give you a quick demonstration of that. So this is just setting up all these sort of common observability tools for Kubernetes specifically, although you can use these for any environment really. And I've set these up in the cluster under node ports here, so we can easily look at them. So we have a Grafana instance here. We have a Jaeger instance, and we have a Kibana instance that we can look at. So if we quickly look at the Grafana instance, you can see that by default with the Prometheus operator, the Cube Prometheus stack, I think it's called, you get a lot of dashboards and functionality just out of the box there straight away. And really some quite decent stuff in here. And of course, you can customize all this and write your own queries, but you can see things like you've got the use method performance monitoring method for this cluster here. Look at memory saturation and CPU usage and things like that. You can look at, for example, SLOs for the actual API server for the cluster itself. So you can see this sort of basic error budget implementation up there, read availability, write availability. So that's very useful stuff. And of course, you can, it being Grafana, you can dig down into any of these. And it's very responsive. And of course, we can pick up any pod here, so we can look in that GitLab managed apps namespace that we set up there. Let's again, Elastic is always a good example of these. You can see a bit of CPU usage there. You can see the memory usage is relatively high, sat between a sort of min and max that we've set up there. You can see the limits, requests and limits for those pods that have been set up, which is really useful. So likewise, the Elastic page here, we can just jump quickly into the discovery section. This is set up on a fluent bit index that's being pushed in. Again, that's getting everything from the cluster, so we can quickly look at the namespace name, have a look in GitLab managed apps there, pull that in. We could pick a particular node for Elastic Master there. What else can we look at? We can get a pod. I've already got some things selected here now. We can expand that and have a look at the logs that we've been getting in. We'll obviously be getting a lot more in it just in the last few minutes as we've been hitting these services and they've been coming in. And likewise, we've got the basic Jaeger interface here out of the box. And I've just configured Grafana to push metrics into Jaeger there. So we can look at, looking at that interface. Grafana doesn't give you particularly interesting traces, but you can see there we hit that data source reverse proxy and we can look at the tags and information there. So it's quite a powerful observability stack that you can set up really easily from this repository just by doing a Helm install, essentially. And there's a make file in there that you can look at to easily set that up out of the box there with minimal effort. Of course, it's not set up to scale. It's not going to handle a large number of requests. It's just set up for experimentation. Anyway, I thought that might be interesting. And that will do for the first video. And I will see you next time.